Okay, good morning, people. Sorry about this very late video to start with you all on a Sunday. Had a great time doing birthday celebrations and stuff like that. Okay, but I said I have to get back to work. Okay, on a very busy week that's gonna come ahead. Okay, so I've decided to push the acids, bases, and salts together for this week. Alright, it's a very big topic and very important topic, one of the most important topics for chemistry. So I hope all of you will hopefully master this. Alright, now let's start off with acids. Okay, my computer is a bit slow today, so please bear with me. Now, as all you know that the ions acids produce in aqueous solutions, let's start off with the three important acids as well as one of the organic acids that you have learned so far. Okay, by now everything should be quite clear to you. The first one is ethanoic acid, it's CH3COOH. Okay, if you dissociate it, it will form H plus and CH3COO minus. Hydrochloric acid, one of the most important acids, HCl, will give you H plus and Cl minus. Nitric acid, HNO3, will give you H plus NO3 minus, and the strongest acid of them all, H2SO4, will give you H plus and SO4 2 minus. Okay, so what do they have? All these acids have in common. Now, if you realize that, okay, all of them have these H plus ions in common. So the H plus ions is the one that makes them qualify to be an acid. So if you want to be an acid, you have to give off H plus, which I think all of you don't have. Okay, so the definition of an acid is a substance which produces hydrogen ions when dissolved in water. This definition occasionally will come out for tests, so I think it will be useful for you to memorize it. It's quite easy for you to memorize. It will only give off hydrogen ions when they dissolve in water. When they don't dissolve in water, then there is no ions. Because if you can recall for the chapter 3 in solid liquid gases, let's say and it came out in prelim 1, like your hydrogen chloride, when it does not dissolve in water, it is not an acid. Okay, so when you put it in water, then it becomes hydrochloric acid. Okay, so next slide is pretty blank. Was it supposed to be designed like that? Okay, all acids contain hydrogen. Okay, this is a disclaimer here. All acids contain hydrogen, but not all compounds that contain hydrogen are acids. Okay, so let's say for example ammonia and methane. Ammonia, of course, is a base. Okay, it's one of those alkaline gases. And methane, okay, even though it has hydrogen, okay, both of them are not acids. Okay, so because when you dissolve them in water, they don't form hydrogen ions. It's as simple as that. So for you to be an acid, you must contain hydrogen, yes. And when you dissolve it in water, you will give out hydrogen ions. Now, what are the physical properties of acids? All of you have learned the physical properties of acids in primary school. They have sour taste. They dissolve in water to form solutions which conduct electricity, and they turn blue litmus paper red. Okay, the more important ones are your chemical properties of acid. This one you have to memorize. It came out in 10-year series before for the last 10 years, so it's a basic thing for you to remember them. Okay, so acids will react with reactive metals to produce hydrogen gas and salt. Why is it reactive metal? If you can recall, copper, silver and gold, they are non-reactive metals, so obviously they don't react with acids. Okay, so this is what you call a word equation. Obviously you don't need to reproduce this in your exams. Step number 2, acids react with metal carbonates to form salt, carbon dioxide and water. This one is pretty standard, as all of you know. Okay, and number 3, acids will react with bases. Okay, bases would mean metal oxides or metal hydroxides. Okay, alkali fall under bases. Okay, some of you all still basically do not know the difference between bases and alkali. Okay, so when it reacts this way, it will form your favorite products. Remember again, salt and water. Surprisingly, during prelim 1s, all of you can only remember salt and water. Okay, so this is not a good thing. Okay, please be able to distinguish what are your chemical properties. Okay, so let's talk about property number 1. When acids react with reactive metals, let's say we use an example of magnesium ribbon to react with dilute sulfuric acid, then you'll get bubbles of hydrogen gas, your effervescence. Okay, and then here is your chemical equation, pretty standard. Okay, and basically magnesium sulfate is the salt that is produced. Alright, now obviously here your sulfate is spelled with SULFATE. So I'd like to reiterate from here onwards, I'd like to reiterate my point again. If it's sulfuric acid, then your salt produced is sulfate. If it's nitric acid, then your salt produced is nitrate. If it's hydrochloric acid, then your salt produced is chloride. Okay, how about if it's ethanoic acid, then it will give you a salt called ethanoate. Okay, of course, the last one you don't really need to know. Okay, now basically this test, okay, it will relate to your practical as well. If let's say you want to test for hydrogen gas, how do you know if there's hydrogen gas? First thing you see is effervescence. Then after that you insert in your lighted splint. Now once your lighted splint is inserted, okay, it will extinguish with a pop sound. Okay, again, just want to remind you guys, okay, if there is no hydrogen gas, then maybe the lighted splint will just extinguish, but there will not be a pop sound given. Okay, so let's talk about whether do all metals react with acids. The answer is no, obviously, because I mentioned it just now. Unreactive metals such as copper, silver and gold, when they add it to dilute acids, there is no reaction. Okay, and also let's say this is just FYI, something extra information. Let's say if you have concentrated nitric acid, when you react, you can react it with metals like copper, but surprisingly it does not give hydrogen gas. Okay, so it will give off a nitrate, water and nitrogen dioxide. That one you don't need to know. Okay, know as well, because sometimes lead, it appears not to react with dilute hydrochloric acid and dilute sulfuric acid. So when you react it this way, okay, this one is very, very important. Sometimes in very, very hard prelim questions they will ask. So let's say when lead reacts with sulfuric acid or hydrochloric acid, it will form lead chloride and lead sulfate. Now the problem is, once it forms lead chloride and lead sulfate, if you can recall for your salts chapter, okay, lead 2 chloride and lead 2 sulfate are both insoluble. So when they are insoluble, when they form, okay, what they do is they will have this this area here. Okay, it's the insoluble lead chloride or lead 2 sulfate. So it will start to coat or cover the metal. Okay, the metal that is balanced or has not reacted with the acid. So when it covers, now what is formed? Now there's 2 layers, and it prevents the metal from reacting further. Okay, this scenario is very, very important. So usually when you have acid reacting with metal, you have to see the product. Okay, sometimes the product is insoluble and it comes with this problem. Okay, alright, so I hope you are quite clear with this. Okay, if you're not quite clear, you can come and see me personally and ask. Okay, I probably draw for you much more vividly. Property number 2, acids will react with metal carbonates to form 3 products: salt, water and carbon dioxide. Okay, let's say for example sodium carbonate and dilute hydrochloric acid, it will form, of course, when you have dilute hydrochloric acid, the salt form will be sodium chloride, water and carbon dioxide. Okay, so this is how the the chemical equation is formed. Okay, now how do you want to test for carbon dioxide? It's very easy. You have learned it practical by now. Okay, you cover the reaction mixture with the stopper delivery tube, and then the opening part of the delivery tube you submerge it in lime water, and then when there is a carbon dioxide, your lime water will form a white precipitate. Okay, property number 3, your acids will react with metal oxides and metal hydroxides to form salt and water only. Again, bear in mind metal oxides and metal hydroxides are bases. Okay, so let's say zinc oxide, when you react it with dilute sulfuric acid, again you will form a zinc sulfate and water. Now for this reaction only, it does not give you any gas. So when you add both zinc oxide and sulfuric acid together in a test tube, you do not expect to see any effervescence. Why? Because effervescence only comes out when there's a gas. For this reaction, there is no gas involved. Okay, so you don't expect to see anything whatsoever. It's just basically that product form is just zinc sulfate. Now let's look at the role of water in acidity. Why is water very, very important in acids? Now let's say you add magnesium ribbon in both hydrochloric acid, and then you realize that look, the right one only produces effervescence but the left one doesn't. So why is that so? Okay, now the left one probably would be hydrogen chloride in organic solvent. Basically it's still HCl, but you just dissolve it in some organic solvent. Could be ethanol, something else, ethanol, propanol, so on and so forth. The right one, okay, you dissolve it in water, hydrogen chloride in water, and then you give off a gas. So when scientists first discovered it, okay, basically they will find out, how come the hydrogen chloride, one is in water, one is in organic solvent? So they realize that the water will give you a special effect where it will release all the hydrogen ions. Remember again, for acids to work, the hydrogen ions must be active. That means must be mobile. Okay, so basically your organic solvent works in such a way that if your HCl molecule is like this, right, it will still be intact together. While the right hand side with water, okay, let's look at it again. Okay, the right hand side is when you dissolve in water, the H plus and the Cl minus will split. Okay, and now your H plus is basically free to go around. Okay, now so your acids will only show the properties of acids when they are dissolved in water. Okay, because this phenomena happens, acids will dissociate in water. Dissociate means produce. Okay, so your hydrogen ions is the ones that are responsible for your acidic properties. Okay, now another example is probably when you have citric acid. Citric acids, they are prevalent in lemon, oranges, lime, and stuff like that. And when you mix it with anhydrous sodium carbonate, solid citric acid, you realize that there is no reaction. Okay, and then anhydrous, of course, when you talk about anhydrous, means no water. Okay, well, all our crystals basically has water. So when you talk about anhydrous, really they evaporate it to dryness and you are left with just powder form. However, this reaction, when you basically add just a few drops of water, then your bubbles of carbon dioxide will form, and then obviously your two other products will form. Your sodium citrate, okay, that's a salt name from citric acid, and your water. Okay, so you realize that water is a main component for acids to basically do its job. Alright, so move on to the next slide. Yeah, that's about it. We've finished our first acid section. Oops, sorry about that. Some pretty girl's picture. Don't worry, not my girlfriend. Okay, so next session we'll talk about bases and alkalis. Okay, so if let's say acid is the good one, the bases and alkali is the evil one, is the opposite, like yin and yang, that kind of thing. So what is a base? Now, a lot of people has a lot of misconception about bases. Basically, people think that bases is just metal hydroxide. Actually, base is any metal oxide or metal hydroxide. Okay, must be metal oxide. Okay, later on you realize that there are a lot of other different oxides. Okay, and sometimes you'll be confused. So let's say, for example, a base will contain either O2 minus or OH minus. Again, the O2 minus must be together with a metal. Okay, so sodium oxide is one of them. And then you have magnesium hydroxide, aluminum hydroxide, so on and so forth. Now, so basically we also, the definition of a base is a substance that reacts with an acid to give salt and water only. Okay. Now, why is it you must have only? Let's give an example of copper 2 oxide. Copper 2 oxide will react with dilute sulfuric acid to form copper 2 sulfate and water. Copper 2 sulfate is the salt. Okay. So this is how the ionic equation goes. Now, let's say if sodium hydroxide will react with nitric acid to form sodium nitrate and water. Now, I just want to bring you to this point, just want to remind you again, okay, this ionic equation is very, very important. Basically, this ionic equation is the only ionic equation for neutralization. So sometimes there are MCQ questions where they ask you, oh, what is the ionic equation for neutralization reaction? Or you recognize those two reactions as acid and alkali, there is neutralization. So you just straight away choose this option. OH minus plus H plus, you get H2O. Why? Because H plus you get it from the acid, OH minus you get it from the alkali, and both of them when they react together they will form water. Okay, so you must memorize that ionic equation. Okay, so let's say for special cases of bases, and now this is when the alkali comes in. Alkalis are known as special class of bases. If you realize an alkali is a base that is soluble in water, okay, so all the other bases are insoluble in water. Now, example of a soluble base is sodium oxide. When sodium oxides react with water, that's where it will come out sodium hydroxide. Okay, so are all bases alkali? The answer is no. Most bases are insoluble in water. Okay, so for example, copper 2 oxide, it does not react or dissolve in water, so it is not an alkali, but however it is a base. So when you react it with acid, it will still do its job. Okay, so most bases are not alkalis. Now, so which bases are alkalis then? Let's talk about, basically alkalis are group 1. Okay, group 1 or ammonium oxides. Okay, so if let's say sodium oxide, potassium oxide, ammonium oxide. Okay, ammonium oxide very rare. Sodium oxide, potassium oxide, as long as it's group 1 oxide, it is an alkali. Okay, it will dissolve in water to form something hydroxide. Okay, now let's say copper 2 oxide. Copper 2 oxide, it does not dissolve in water. Okay, so it will not form copper 2 hydroxide. So remember all your chemical analysis precipitates, all of them are precipitates, so they are not soluble in water. Their state symbol is solid. Okay, so what are the properties of alkalis then? Now alkalis, these are physical properties. Alkalis have a bitter taste and soapy feel, okay, like detergent and that. Alkalis will turn red litmus paper blue, is the opposite of acids. Acids will turn blue litmus paper red. And alkalis will produce hydroxide ions when dissolved in water. Now please take note, these are only for alkalis but not for bases. Okay, so now let's look at property number 3, because property 1 and property number 2 are self-explanatory. Sodium hydroxide, okay, when you dissolve in water, okay, you form sodium ion and OH minus ion like this. Okay, so basically your aqueous represents water, and then for example, let's say your calcium hydroxide, it will give you calcium ions and hydroxide ions. Okay, property number 4. Okay, alkalis will react with acids to form salt and water only. You call this process neutralization. Okay, so as I was telling you, the ionic equation for this is basically H plus OH minus to form water. Let's look at an example. Let's say sodium hydroxide and hydrochloric acid. Okay, alkali, acid to form salt and water. So the chemical equation will be in this way, and then your ionic equation will be voila, like this. So for all neutralization reactions, all your ionic equation will look something like this. Okay, now which reaction is neutralization? Okay, let's see. Remember, your neutralization will give you salt and water only. Now for this case, you have manganese oxide and hydrochloric acid. Now manganese oxide will, sorry about that. Manganese oxide will behave in two ways, MnO2 and MnO. Okay, so which one is actually a neutralization reaction? You realize that the first one is the neutralization reaction because it will produce salt and water. The second one is not, because it produces salt, water and chlorine. So as long as it produces something extra, it is not a neutralization reaction. Property number 5 is the one that always a lot of people forgot. Alkalis will react with ammonium salt. Ammonium salt refers to ammonium chloride, ammonium sulfate and ammonium nitrate. It will give you three things: salt, water, and ammonia gas. Now this reaction is somewhat similar when acids react with metal carbonate. So sometimes I don't get it why students actually forego this, maybe because it seldom came out. Okay. Now obviously when ammonia gas is given off, okay, you will realize that it gives off a pungent smell. And then when you test it with litmus paper, damp red litmus paper, then it will turn blue. Okay, that's one of the tests for ammonia gas. Now, when calcium hydroxide is heated with ammonium chloride, okay, same thing also, okay, it will give you ammonia gas. Okay, so there's the chemical equation, and there's the ionic equation. Now, the ionic equation is somewhat different. I believe you all can right now construct it from ionic equation from chemical equation. Okay, if you have not, please do come and see me. Okay, that's about it. So bases and alkali we have covered. Okay. What is that pretty good picture there? Okay, so let's look at pH scale here. Okay. Alright. Now, what is a pH scale? A lot of you seem to forget this section of the acids bases topic. Now, pH scale actually lies on the range of 0 to 14. Okay, and I can actually tell you whether a solution is acidic, neutral, or alkaline. Okay, so acids have a pH values of less than 7. Okay, and alkalis will have pH values of greater than 7. So basically your neutral solution will only have a pH of exactly 7. So anything that is here is acids. Okay, anything that is here is alkali. Okay, this one is neutral. Okay, now let's say now pH of let's look at pH of some common substances. Your sulfuric acid, nitric acid, and hydrochloric acid, they are pretty strong acids, so they're actually the pH is actually about 0 to 1. Your ethanoic acid is one of your weaker acids. Okay, when you talk about organic acids, those carboxylic acids and so on and so forth, okay, they are very weak acids. So basically the pH scale is probably from 3 to 4. Pure water, of course, is neutral, may belong to 7. Aqueous ammonia, your pH scale probably lies around 9 to 11, very weak alkaline. And sodium hydroxide, potassium hydroxide, calcium hydroxide, they are one of the stronger alkalis, so their pH scale probably be 14. Okay, now how do you determine the pH of a given solution? You either use an indicator or pH probe attached to a data logger. So nowadays we have this computerized system. It looks like a handheld game. Okay, you just connect it to a sensor called pH probe. Then it will straight away, when you submerge the pH probe into the solution, it can tell you the exact pH of the acid or alkaline. Okay, now your pH value of a solution can be determined usually using a universal indicator. Now universal indicator contains a mixture of dyes, and it will give different colors in solutions of different pH. You don't need to know what dyes are actually used in making pH indicator, universal indicator. So usually the pH of a solution is calculated based on the concentration of hydrogen ions or hydroxide ions present in solution. So obviously if it's an acid, then it will contain more hydrogen ions than hydroxide ions. If it's alkaline, then vice versa, it will contain more hydroxide ions than hydrogen ions. Okay, this graphic nature will actually explain to you. Okay, acids with a smaller pH value have a higher concentration of hydrogen ions. So let's say the stronger the acid, then obviously the majority is hydrogen ions. However, if it's alkaline, then you will have a larger pH, then it will have a higher concentration of hydroxide ions. However, how about if it's neutral? Then if it's neutral, let's say it has an equal concentration of hydrogen and hydroxide ions. Okay, now your pH also can be used to compare the strength of acid and alkalis of the same concentration. So let's say if it's the concentration of hydrochloric acid has a pH of 1 of 0.1 mole per dmq of hydrochloric acid, it is a stronger acid, let's say, compared to a same concentration of ethanoic acid which has a pH of 3. So provided that it has the same concentration then of two different acids, then you can compare the pH. Okay. Now, why is the importance of pH? Why is pH very important? Okay, this one please take note. Usually it will come out in MCQs. Okay, soil pH is important because it affects, okay, the growth and development of plants. So usually for plants, they can grow the best when it's neutral or slightly acidic, probably about pH 6 or 7. Okay, now plants will not grow in soil that is too acidic, obviously, because the roots will crumble. And when this can, sometimes it happens when too much fertilizer is added to the soil. You know, sometimes fertilizers, people don't realize that it basically gives nutrients to the soil, but too much of it is not good because it makes the soil too acidic. Okay, another reason why soil can become too acidic because of acid rain. As you know, our rain is quite acidic. Okay, probably could be 4 to 5 or pH 4 to 5. So sometimes when it falls down to the soil, when there's too much rain, then the rain becomes acidic. Okay, so usually how you control the acidity of the soil, you add chemicals to it. And essentially what chemicals you add? Quicklime. Okay, now please take note, quicklime and lime is the same, slaked lime is different. Okay, so sometimes you add calcium oxide is quicklime, calcium hydroxide is slaked lime. This is called liming of the soil. You add lime to it. Okay, but usually for, let's say, very importantly, let's say if you want to remove excess acid from the spillage and stuff like that, usually you just okay, my iTunes is jumping around. Okay, so basically, so you want to remove excess acid, I would recommend that you use carbonate. Why you use carbonate? So that when you use carbonate, you just basically whatever product they will get is neutral, rather than you use calcium oxide or calcium hydroxide. Sometimes when you add too much alkaline, okay, your soil is now too alkaline instead. So usually for MCQs, look out for the carbonate first. Okay, if there's no carbonate, then you can look out for calcium oxide and calcium hydroxide. Okay, that's it for pH scale. Okay, let's look at the last one, types of oxides. Okay, is the one that I think forgotten. Okay, right, this is the last section. Okay, an oxide is a compound of oxygen and another element. Okay, let's say an oxide usually ends with the element oxygen. So most oxides can be categorized into 4 oxides: acidic, basic, and amphoteric, and neutral oxide. Now, the first type of oxide is acidic oxide. Acidic oxides, okay, can only form from non-metal oxides. So acidic oxides are often gases at room temperature. They have low melting and low boiling point. Okay, and most acidic oxides, when they dissolve in water, they form an acid. Okay, so let's say for example sulfur dioxide, when dissolved it readily in water, it will form sulfurous acid. Now what is the formula for sulfurous acid? Sulfurous acid is H3SO4. Now your sulfurous acid H3SO4, what is H3SO4? Sorry, I take that back. It's not H3SO4, it's H2SO3. Okay, so sulfurous acid is H2SO3, and then it can oxidize to form H2SO4, and H2SO4, as you know, is sulfuric acid. Okay, so let's say for carbon dioxide, okay, when you dissolve it in water, it will form carbonic acid. Carbonic acid is found in soft drinks. Sulfur trioxide, when you dissolve it in water, it will straight away form sulfuric acid. Phosphorus oxide, it will dissolve in water to form phosphoric acid. Okay, now acidic oxides do not react with acids. Obviously, you cannot have acid and acid reacting together. Okay, however, they do react with alkalis to form salt and water because they function as acids. Okay, so when they react with alkalis, they form salt and water, and it's called neutralization reaction. Okay, now the next one is what you call basic oxides. A lot of people tend to remember oxides as basic oxide. That's about it. They forgot about acidic oxide, amphoteric oxide, and neutral oxide. So basic oxides, basically, as its name implies, okay, they are metal oxides and they react as bases. They act as bases. Now basic oxides are often solids at room temperature. That's because they are ionic compounds, so they have high melting point, high boiling point, and they are usually insoluble in water. So a few of these oxides actually dissolve in water, sodium oxide and potassium oxide. So if let's say they are group 1, okay, group 1 oxides, then they dissolve in water, and when they dissolve in water, they will form alkali. Okay, very simple stuff. Okay, so let's say for example quicklime, calcium oxide, when you react it with water, it will form a vigorous reaction. Calcium hydroxide is actually sparingly soluble in water. Lime water actually, you see, is actually sparingly soluble. Sometimes it's soluble, sometimes it's not. Now basic oxide, that its name suggests, reacts with acid to form salt and water. It's neutralization reaction. Okay. So next one, we look at amphoteric oxides. Now amphoteric oxides, you look at these two reactions. Okay, first one, you have hydrochloric acid and zinc oxide. You form zinc chloride and water. No problem with that. So basically, for the first reaction, your zinc oxide behave as a base. Now let's say you put zinc oxide and sodium hydroxide. Okay, it does react also, but it will form this thing called sodium zincate. Sodium zincate is a particularly complex salt, which is not inside your syllabus. But one thing that you need to know of that here is your zinc oxide actually acts as an acid. So how now? This one like a bit like char aqua like that. Okay, amphoteric oxide behaving like base and acid. So in this case, there is a special name for it. Okay, and it's called amphoteric oxide. Okay, so in both reactions, the zinc oxide behave as an basic oxide, the other one behave as an acidic oxide. So in both cases, it will form salt and water. So zinc oxide is an example of amphoteric oxide. Okay, and basically amphoteric oxides are metallic oxides that react with both acids and bases to form salt and water. Okay, so what are the other amphoteric oxides really? Okay, I think you all should remember this. The other ones are aluminium and lead 2. Okay, aluminium and lead 2 oxides are amphoteric oxide. Wait, is that right? Zinc, aluminium and lead 2. Okay, correct. Okay, now last one is neutral oxide. Neutral oxides really are pretty useless because they are actually non-metal oxides that show neither basic nor acidic properties. Okay, so neutral oxides are basically insoluble in water, and the most famous neutral oxide is actually water. Water, if you can recall, is H2O. It ends off with O. Second one is carbon monoxide. Okay, this one please don't confuse with carbon dioxide. Carbon dioxide is acidic oxide. Carbon monoxide, neutral. Then the last one is nitric oxide. Okay, that's about it, right? Okay, so how do you classify an oxide? Okay, basically you ask yourself this question. That's what happens when your computer is lagging. Okay. Hey, alamak. Wait. Let me accelerate through everything. Bear with me for a while. Okay, so basically how do you want to identify oxides? Either you memorize them or you can follow this table. You ask yourself, does the oxide dissolve in water, in acid? If yes, then it could be either basic or amphoteric. Okay, if it's soluble in alkali, then it is amphoteric. If it's insoluble in alkali, then it's basic oxide. Now, let's say if it's not able to dissolve in acid, then it's either acidic or neutral. If it's soluble in alkali, it's acidic. If it's insoluble, it's neutral. So I would not recommend that you remember this chart, but if you can remember through this chart, then it's fine. But I would suggest the way I would remember it is to memorize. Okay, so that's about it for acids and bases. 35 minutes, almost 35 minutes of talking. Okay, I'll be back with the salts chapter. Okay, and then after that, then we're done for this week. Okay, thank you very much. See you later.